Hi, in this session, let us look at the law of conservation of energy. According to this law, energy can neither be created nor can be destroyed. It can only change from one form to another. So now let us look at the case of a freely falling body and the total energy at different positions. Let us take a body of mass m, which is at a position A at a height of h from the ground. So at A, the total potential energy of the body is equal to m into g into h, h being the height above the ground, m is the mass of the body, and g is the acceleration due to gravity. So this is mgh. So at that position, the potential energy is mgh. Now, the kinetic energy at that point would be half m u squared, u being the velocity of the body at that point. Let us consider that at that point where we are going to just start, the initial velocity u would be 0. So when u is 0, the kinetic energy would be half into m into 0 squared, which is nothing but 0. So the total energy at A is equal to potential energy plus the kinetic energy. The potential energy plus the kinetic energy is mgh plus half mv squared, but here the kinetic energy is 0, and so the total would be mgh. Now let us take another situation of the body having started at O and it's falling down and it reaches a position B. Now let us consider that it has gone through a distance of x. Here the initial velocity was 0. So now at B, to find the velocity of the body at B, we would be using one of the three equations of motion that we have studied earlier. That would be v squared is equal to u squared plus 2gh. Whereas here the case is how much distance it has gone, it would be x. So it is 2gx. So the initial velocity is 0, so this would be 0, and the velocity at this point is, let us take it as v1, so that we differentiate it if we take a velocity at a different point. So 0 plus 2gx. Okay, so v1 square would be 2gx. The potential energy at this point would be m into g into the height above the ground. So the height above the ground here is, the total is h. This the distance here is x. So this would be h minus x. So the potential energy would be m into g into h minus x. So the kinetic energy is half m v1 squared, which would be half into m into 2gx, because we found that v1 squared is 2gx. So which is nothing but, I cancel the 2's and it becomes mgx. So the total energy would be mg, the potential energy plus the kinetic energy. Potential energy is mg into h minus x plus the kinetic energy, which is mgx. So now that would be nothing but mgh minus mgx plus mgx. So I can cancel these and I get mgh. So the total energy at B is mgh. Now let us consider a point C just before it hits the ground. It's almost there. It's not hit the ground, it's just there. So at this point, what would be the velocity of the body? The initial velocity was at, let's do this at C. The initial velocity was 0. Now the distance it has traveled is h, and the distance it has traveled is h, and so now the velocity at this point is v squared is equal to u squared plus 2gh, which is nothing but 0 plus 2gh, or v squared equals 2gh. So here the kinetic energy would be half mv squared, which is half into m into 2gh. 2 cancels and we get mgh. The potential energy would be mgh, but the height here is 0 since it is just near the ground. So there's no distance above. So it is that would be 0. So this total is 0. So the total energy at C is mgh plus the 0, which is mgh. So we see that the total energy at A is equal to total energy at B, which is equal to the total energy at C. So the kinetic energy is in either in the form of that is the mechanical energy is either in the form of kinetic energy or potential energy or a mix of both, but the total always remains constant. And in this case, we have this over here, mgh. We found it with our derivation. Hope you all understood it. If you have any doubts, you can always message me.